welcome back. Previously we were discussing about various terminologies with regard to set theory, in which we have discussed numerous terms that is associated with set theory. Let us continue with that. Next one, intersection of two events. Usually we will be using an example case of set A and set B. There is no rule that we will only use A or B. In most cases we will be using A as well as B. So what is the meaning of set intersection? In the previous some of our session we have discussed about the concept of intersection. The intersection of two events A and B is denoted by A intersection B. Remember the sign in the question. You will be come across a case where signs will be used instead of the terms intersection, so you have to familiar with the signs. So whenever two sets are intersected likewise, so it is represented by like this. Whatever the name of the sets, A, in this case it is A and B, so A intersection B is the set of same sample points common to both A and B. For example, if A set means all those numbers that includes getting the multiple of 5, and B set means all those numbers having the multiples of 3. So A intersection B means getting the multiple of 15. We all know that if you take the multiples of 5, in one case you will get 15, and if you take the multiples of 3, you also get a case of 15. So A intersection B means the number in which the 15 comes common. That is the concept. With another example you will get the clear picture. For the time being we will be using a simple example. See, you can see that here there are two circles. One circle represents, let it be set A, another section or other set represents set B. In first set is known as all those persons who are interested or playing soccer. Soccer means football. And the second one means all those persons who love tennis. So now we are discussing intersection. Intersection means the numbers or persons or values common in both cases. So if you verify the names here, that in soccer there will be Alex, Casey, Drew and Hunter. These are the names of the persons who like to play soccer. And here also three persons who are interested in tennis. If you look closely, you can see that here two persons play both soccer and tennis. That is common to both areas. So it can be written as like this. See, intersection, the figure will be written like this. Two circles intersect. A certain area will be within both lines. One set represents soccer, another represents tennis. So the two persons who play both games are Casey and Drew. I hope you have gone through the names in the example case. So if you write the same in the picture format, the picture will be like this. So this area represents intersection. Remember, intersection is represented by the area in which both sets intersects. So this is the area of intersection. I hope you have got an idea regarding that. Let us go to next one. Next one, difference of two events. I hope we have learned the same area previously. Difference between two sets is the other meaning of difference of two events. Usually we will be using the examples A and B. So difference of two events means if you are studying A and B, A and not B, we can say like that. Or otherwise we can say it means difference of two sets means only A. Only means only one set. Other sense we can use the term exactly A. Then why we are using all these? Because in the question you may come across all these terms. All these terms are synonymously the same. So in the question case they will be explaining during the explanation part. Instead of using difference of two events, they will be using any of these three terminologies. So you have to be familiar with the meaning of all these three situations. Whenever exactly a name of the set is given, that means the difference of two sets. So whenever you come across only in the name of a particular set, that also means difference of two sets. And whenever it is like this, A not B means difference of two sets. So what is the meaning of difference of two sets? The events A and not B, or only A or exactly A, is an event whose outcomes are those belonging to A but not B. Therefore, A not B excludes from A outcomes common to A and B. The same thing can be expressed in an equation form. It will be like this. Whenever you come across a difference of set, it will be written like this: A not B, otherwise known as only A or exactly A. It can be represented as A intersection B complementary whenever a set is followed by a superscript dash or a small c. It means complementary. I hope you all know what is the meaning of complementary. We are not going further into that. So it will be written like A intersection B complementary. It can be written in a simple form, that is A minus B. I hope we have learned this one, A minus B. The same thing can be expressed in quite detailed format, that is like this. Difference of two events can be written as whatever the names which we are using. Usually it will be A and B. The equation will be A minus A intersection B. That is the equation when it is expressed with regard to difference of two events. With a simple example, you will get a clear picture. Earlier we were discussing the example where two sets of persons, one set represent playing soccer or football, another set represent playing tennis. So we are going to represent the same with the differentiation concept. So how we are going to represent? Differentiation means if you are representing any particular set, it should include or it should consider those items or persons or events that is only exist in that particular set. It should not be there in the second or following subsequent set. That is the meaning of difference. So if you go through it, you can see that in the first set, 4 persons play soccer: Alex, Casey, Drew and Hunter. Tennis is played by Casey, Drew, Jay. So if you look closely, you can see that Casey is there in both cases. Drew also there in both cases. We don't know anything about Jade, so we are not considering Jade, because here we are discussing differentiation or difference of two events, particularly considering the first set known as soccer. So we need not have to worry about Jade. We only consider only those items that is especially there in first set and it should not be there in tennis. So if you can see that Alex is not there in tennis and Hunter is also there, not there in tennis. So these two are the persons representing the difference of two events. So how we are going to represent it pictorial form? It will be like this. See, two sets are joined together, soccer, tennis, and we should consider only those events that is especially there in soccer. And we have mentioned that Alex and Hunter were the two persons that are playing especially soccer and not tennis. So it will be shown in the picture like this, where we will shade only this area. See this area, because events or persons that are especially there in first set, and we does not include all these areas, because in this area we are not considering, because we are studying only about this difference with regard to soccer. If it is learned with regard to tennis, we could have selected this area. We are learning the difference concept with regard to soccer, so this area doesn't include. And we all know this one because we have just learned about it. It is intersection that is common in both areas. Now we are learning only difference concept, that is numbers, events or persons that are especially there only in the first set. First set means soccer. So picture will be like this. So why I mentioned here that in the slide or in the previous slide we have shown an equation where A minus within brackets A intersection B. So let this soccer set be A, and from this A we only taking this part alone. And if you look closely, you can see that the soccer circle or the first set includes two parts. This part, the area shaded in light violet, and another one, this one in white color. What is the meaning of this area? Yes, this area is represented by intersection. So if you are selecting or finding the difference with regard to a particular set, you need to select only this area. So it can be represented in an equation. Entire name of the circle be A, and you need not have to take this area, that means intersection. So it can be written as A, out of which we need to remove this one. So minus this area is represented by intersection A intersection B. That was the equation which we have learned just now. See, this was the equation A minus A intersection B. I hope you understand the concept. That is why we are using the equation. You need not have to worry about how this equation developed or created. You just understand the concept, how this equation came with the figure. That is the concept. So I hope you understand the concept. If you have any queries, please let me know. Next one, exactly one, otherwise known as symmetric difference of two events. So what is the meaning of exactly one? And you may think that we already learned a concept exactly A. Then what is the difference between exactly A and exactly 1? So the simple example is, with the explanation we will get the picture. If A and B are two events, exactly one of them is the event whose outcomes are in A only, or it may be in B only. That is, the outcomes common to A and B are excluded. I hope you have got the difference between this one and this one. Here also exactly A, here also exactly 1. What is the difference? In difference of two events, you will be studying exactly A means if it is a case of A and B, the first set is taken into consideration. That is, that particular one only taken into consideration. That is known as exactly A. Exactly 1 means it can be it is also a concept of difference of two events. The only difference between this one and this one is, here we will consider only exactly whatever the first set which is given, that is only taken into consideration. But in exactly 1 you will take both sides. Both sides means it can be a situation of exactly A, or it can be a situation of exactly B. That depends upon the situation. That is, in here we will consider both the events. It can be A or it can be B. It can be A or B means exactly A or exactly B. But in case of difference of two events, you will study only exactly A. Nothing about exactly B. That is the concept. So the equation will be like this. Exactly 1 usually represented like this: A intersection B complementary union B intersection A complementary. If you look closely, you can see that we already learned this area. See, A intersection B complementary, and it is represented like this: A minus A intersection B. So sometimes you come across a situation where the same can be expanded like this. So don't get confused. A intersection B complementary means A minus A intersection B. So if in the case of A intersection B complementary is like this, then surely you will come across a case where B intersection A complementary. How we are going to represent it? It's simple. Just replace the letters A with B. So it can be, if the B intersection A complementary is written like this, it will be like this: B minus bracket B intersection A. That's the concept of exactly 1. If we are expanding this area, you will return this one union, after that the other way around. That is the same with the letters exchanged to the opposite sides. I hope you have got a glimpse into that. Don't worry, we will discuss these areas in detail when we are dealing the practical cases. Right now we are just going through all these terminology with regard to probability. You need not worry about it, just understand the concept, familiarize these equation terms and symbols. We will look into the matter when we are coming to the practical area. So these are the basic terminology with regard to probability, and there are many terms with regard to probability. We are not going into that. During the course of discussions, whenever new terms comes, we will discuss about that. So these are the terms which you have to be familiar with, because these are the commonly used terms with regard to probability. So familiarize each term, because you may come across all these terms in the course of practical cases. So in order to understand the concept of the question, you need to have an idea about the meaning of each terms. So let us go to the main area. Different definitions of probability. We have learned about the concept of probability, its meaning, terms with regard to that, and with regard to different definitions. That means from different angles the probability can be computed. Even though the core and the basic concept remains the same, some variations are there with regard to its point of view from various angles. So that is the meaning of different definitions of probability. These are the three major differences with regard to the definitions of probability. There is a definition with regard to classical definition for probability, another one empirical definition for probability, and finally modern definition for probability. We will be discussing each area in detail. First one, classical definition of probability, otherwise known as a priori or mathematical probability concept. So classical definition of probability is just like the basic concept which we have learned at the beginning of this theory where probability has started. The same concept has been explained again. So let's go through a glimpse into that. The classical concept of or classical definition of probability, otherwise known as a priori or mathematical probability, this concept was introduced by mathematicians James Bernoulli and Laplace. These were the two elementary persons who have implemented the concept of classical definition. They mentioned that if a random experiment produces only a finite number of outcomes, let it be n number of outcomes, and all these outcomes be equally likely or mutually exclusive, whatever may be the situation, let f of these outcomes be favorable to an event A, then the probability of the event A is defined as the ratio between f and n. So it can be defined in the form of an equation P of whatever the name of the event equal to f divided by n. F means number of favorable events that is going to happen, and n means total number of events that is going to happen. So this is the concept of probability. I hope you have understand the concept because we had discussed the same case again and again. So this is a simple concept of probability where the situation, if you are conducting a random experiment finite times, finite means number of times is limited which can be measurable. So there will be two items. A is the name of the event. Earlier we have learned is the set A, set B, like that. So whatever is the name of the event, let it be A, and probability of whatever event which you are going to study. Here is the case of A, so you will be using whatever the name of the event within square curly brackets equal f divided by n. F means number of favorable events. If you are studying how many times the head going to happen if a coin is tossed, means we know that if a coin is tossed one time only head will happen, so favorable event means 1. N means how many events can happen if a single coin is tossed. It is 2, because if a coin is tossed you might get head or you might get tail, so there are 2 events. We have learned the same case earlier, so here we have discussing in a theoretical concept point of view, so don't worry about it. So probability of whatever the event is represented by f by n. With an examples you will get a clear picture. What is the probability of selecting a boy from a class containing 25 boys and 30 girls? So what is the probability of selecting a boy from a class containing 25 boys and 30 girls? So probability of getting a boy means favorable events by total number of events. So here it is, you are asked to find probability of selecting a boy. So selecting a boy, how many boys are there? There are 25 boys. So the chance of getting means 25 times, because there are 25 boys. So we are asked to find what is the probability of getting a boy means. So in that class there are 25 boys. So favorable number of cases is 25 and total number of cases, how many students are there? 25 plus 30. That is the concept of probability and can be represented in an equation format like this. Probability of getting, you can usually write boys within the brackets. For the time being I am using a capital B. Whenever you are dealing with a probability case, within the brackets whatever event you are going to study, that mention that in the brackets. So probability of getting or selecting a boy is 25 divided by 55. That is the concept. I hope you have understand the concept. You may think that what is the probability of selecting a boy? For selecting one boy, and then it could have been 1 by 55. No, if the strength of the class includes only one boy and 54 girls, that was right. But here selecting a boy out of how many boys? 25 boys. You can select any one of these 25 boys. So probability of a boy means you have the probability of selecting in 25 times, 25% chance. That is a concept of meaning. So 25 divided by total number of students. That is the concept. So another example, 3 coins are tossed. What is the probability of getting? So regarding the probability, there will be different cases. So whenever you come across where 3 coins are tossed or 2 coins are tossed or 2 dice are tossed, when one coin is tossed and one dice is not, it is not issue, because we know that if a coin is tossed there will be 2 events, head and tail, head and tail, tail and head, likewise. So don't worry. But if whenever there are events that are more than 2 events, that is two coins are tossed, 3 coins are tossed, or 2 dice are thrown, 3 dice are thrown, whenever you come across such a question, before you go into the application part, try to write down the events like this. See, here we are discussing about 3 coins. So what is the probability of getting? Whatever the case, we will discuss that. So before we go into that, try to write down the sample space. Sample space means events that is going to happen. If 3 coins were tossed, it will be like this. See, if I have dropped or I have tossed 3 coins, I might have got 3 heads. That is one event. Sometimes I might get 2 heads, 1 tail. If I toss again, I might get head, tail, head. That will be the order. I hope you understand the concept. Again, if I toss the 3 coins, I might get a combination like this. First one I would have got tail. With the second coin I could have got head. With the third coin I would have got head. This is also a chance. If I have thrown like another style, I would have got first one head, second coin tail, third coin tail. So you have to write down how many combinations of cases that can occur. That has to be identified. Whenever you come across a coin, like when 2 or above coins are tossed or 2 or above dice are thrown, kindly do like this. Then only you can easily identify the answer. So for the time being, 3 coins are tossed and I have noted down all the events that can happen. And don't repeat the event again. That means head, tail and head. Don't write again head, tail and head. So try to identify events that can happen and think logically. It is very easy. Think logically, and once you write down all the events that are going to happen, that can happen, next you will go to the question part. First one, what is the probability of getting all heads? It will be 1 by 8. See, 8 means 1, 2, 3, 4, 5, 6, 7, 8. Denominator represented by total number of cases. So 8 will be the value for whatever the question that is asked with regard to this question in the denominator side. So all heads. See, there are 8 combinations. How many cases you can see that all the items are head? See, full tail, 2 tail, 2 tail, 2 tail, 1 tail, 1 tail, 1 tail. See, finally 3 heads. So in the question it was said that all the 3 cases head, because here the question was through 3 coins are tossed. So there is only one time we have got all the three coins head. See, so the probability of getting all head is 1 by 8. So whenever you come across a question, try to write down all the sample space with regard to particular case, then you can easily identify the answer. Next one, two heads. How many cases are there? You get two heads. See, this will not come, only two heads only. See, two heads, two heads, two heads. From here on, everything is 1 and nothing. So there are three events with regard to two heads. So it will be 3 by 8. Next one head. How many events that include one head? See, here it is 3, here it is 2, here it is 2, here it is 2. Here it is 1, 1, 1. So again the answer is 3 by 8. And finally, at least one head. Okay, that is a term which you will come across a question with regard to probability. At least one head means 1 and above. Whatever the number, that particular number and above. It can be one head, it can be two heads, it can be three heads. That is the meaning of that concept. So if you that is the meaning of this term, at least one head. So whenever you come across a term, at least whatever the number, that number and the following numbers. So at least one head means you can go for even where one head comes, or you can go for even where two heads comes, and you can go for even where three heads comes. So this can be included. Three heads, two heads, two heads, two heads, one head. It's okay because at least one head. So we can include this one. One head, one head. See, here is only case where no head comes. So the question was at least one head means the events that include one head and above. So there are 7 events because only in this event there is no head. In all other events there are at least one or above one time heads. So it is 7 by 8. And finally, at least two heads. At least two heads means also the same case. Remember, at least two means 2 and above. 2 and above means here it is 3, we will include that. Here it is 2, we will include that. 2, we will include. 2, we will include. From here on, all are 1 heads and nothing. Here we are asked to find the probability of at least 2 heads. At least 2 means 2 and above. See, 1, 2, 3, 4. So probability is 4 by 8. And finally, another term, at most one head. Remember, at least is and at most. These two are different. At most one head means 1 or less than 1. That is the meaning. 1 or less than 1. That is the opposite of at least. So in at most one head means 1 or less than 1. So see what are the cases in which there are one head, here also one head, here also one head. At most one means 1 or less than 1. Less than 1 means 0. So the even where no head comes, here the only one even where no head comes. So 1, 2, 3, 4. So probability of at most one head means 4 by 8. So this is how you need to find the probabilities with regard to events like tossing coins or throwing a dice. Remember, whenever you are come across a question where dice or coins were thrown or tossed, look for the events. If there are events that are more than more than 2 coins are tossed, or 2 dice or more than 2 dice are thrown, in that case try to write the sample space like this. And remember the term at least and at most. At least means whatever the number given, consider that number and more than that number values. So here it is at least 3 means 3 and above. 3 and above means 3, 4, 5, 6, 7 likewise. At most 3 means numbers less than 3. So it includes 3, 2, 1, 0. That is the meaning. So let's go through it. We will discuss about the further cases in the next one. and familiarize all these terms. If you have any queries, please let me know.